So in the previous video, right, we saw that this superheterodyne process results in better performance because you're using filters at lower frequency. So let's take a look at what this means in practice by looking at some numbers. So let's say that you have an AM radio and you're trying to, and you have an intermediate frequency. So this is the intermediate frequency is 455 kilohertz. So this is the frequency. You have some factory tuning that tunes at 455 kilohertz. So now when you do this, right, we'll say that we have two different processes. We have the superheterodyne and the subheterodyne. So why would we use the superheterodyne compared to the subheterodyne? So the superheterodyne process, we would say in our mixer, right, we're going to add our carrier frequency and the intermediate frequency, right? It's an addition process, whereas the subheterodyne process is a subtraction of the intermediate frequency. And the superheterodyne process is preferable because this will result in smaller tuning ratios for you. So for our superheterodyne process, when we add a channel together, right, this is the ratio of frequencies that we would need to use. So when we're mixing them together, the bands go from 530 to 710. And so when we add them together, right, the ratio between the smallest and the largest is only 2. However, with the subheterodyne process, when we're trying to tune between the minimum and maximum bands or channels that you can get, this is going to result in a ratio that goes from 95 to over 1,000, 1,100. And so this is a really big ratio, a frequency ratio that you have to deal with if you use the subheterodyne process. So this is why radios use the superheterodyne process, and many things use the superheterodyne process, where your mix, right, your mix frequency is going to be the sum rather than the difference. So the superheterodyne process has smaller ratio between the minimum and maximum values, and that makes it a little bit easier to tune. So when you do this, right, it means that it's easier to tune between these two, and this means that these oscillators are a little bit easier to tune, a little bit cheaper to tune. So the higher this ratio is, the harder it will be to tune, and the worse result you would get. And this is why the superheterodyne process, adding your carrier frequency and intermediate frequency, is preferable to the subheterodyne process.